Welcome to today's class. As we are preparing for this year WAEC, we'll be tackling series of questions, and today we are handling moments. Just like you can see, we want to tackle this question. Determine the magnitude of P in the diagram above. But before we solve this calculation, I want you to note four things about moment. The first thing I want you to note is that moment, definition of moment is the product of force and distance. Remember that force is mg, or you can use ma, but we are using mass in this case. So this time around, if you see mass and force, multiply it with the distance. That's the first thing I want you to note. You can see, use mass, force, mass, distance, force, distance, anyone given. These are the two major things we need to solve this calculation. Then another thing I want you to note about moment is the unit. The unit is Newton meter because it's product of force and distance. Then clockwise moment is equal to anti-clockwise moment. Clockwise moment is equal to anti-clockwise moment for a body in equilibrium. For a body in equilibrium, you take moment about the pivot. Moment must be taken about this point. These are the things I want you to know. Clockwise moment is equal to anti-clockwise moment for a body in equilibrium. That is a body that is balanced. Okay? Then another thing I want you to note is that when we have a vertical force like this, in the y-axis, please use sign. Now, if we have it in the horizontal direction, that's the x-axis, use cos. Please don't forget it. As I teach, I preach and talk to my teenagers, to my students. I tell them that if you're standing discussing rubbish with a boy, an opposite sex is a sin. You're talking about boyfriend, girlfriend, wasting your time, please, is a sin. Now, for those people that have lost their conscience and they are eating deep into sin, they go as far as lying down horizontally to do what is not supposed to. Please, that is to me a serious cause. The person is about incurring cause. Please, I used to tell them, whenever I'm teaching this topic and I get to this point, I always tell them this. Most of them will laugh, you are funny. It's not about being funny. It's about passing, teaching physics, and also preaching to them not to sin or curse themselves by going to lie with an opposite sex that they are not married to. So when it's vertical, it's sin. When it's horizontal, you use cos. Now, hope you are enjoying the class. Don't mind me. Okay, we are going to solve this question now. Please like this video, subscribe to this channel, share this video. Let's go. Subscribe, please. Thank you. Let's go. Now, we want to solve this problem. Determine the magnitude of P in the diagram above. So what we are going to do is, we are going to say, let this body be in equilibrium, so that we'll resolve this P to be, let's resolve this P to be a vertical force. That means that this angle, we'll use it and say P sine 30 degrees. Why are we using 30? Because we are resolving it to the vertical direction. Remember, you use sine. Now, we have another force here, which is 40 Newton. And then the distance from this point to this point is 30 cm. The distance from this point to this point is 20 cm. Then we have the pivot here. Please, we take moment about the pivot. So we are going to resolve this first now, since it's no more P, but now P sine theta. We are going to say clockwise moment. Let's take moment about like this, about the pivot, and then resolve this force about the pivot. Clockwise moment is equal to anti-clockwise moment. We have that. We are going to say P sine 30, that's taking moment about this pivot, is equal to, remember this is P sine 30. What about the distance? The distance from here to here, this is the fourth, is 30 plus 20, which is 50. Now that 50 divided by 100, so that the 50 cm is going to be 0.5 meters. So this is the force that we have, 0.5 times this. Remember, this is the force. It's no longer P, but P sine theta. Force times distance from here to here is equal to, what's the distance here? 20, which is 0.2. Then 40 times 0.2. Remember, I changed 20 cm to meters by dividing it with 100, so that it will be in standard unit. So we now have that sine 30 is 0.5 times 0.5. So here we are going to have here to be 0.25p is equal to 40 times 0.2, which will give us 8. So P is going to be 8 over 0.25. 8 over 0.25. Divide by 0.25. That will give us 32 Newton. That is the answer to this question. Hope you understand it. Always take moment about the pivot. So let's go to the next question. The next question, a meter rule is found to balance at the 48 cm mark when a body of mass 60 grams is suspended at the 60 cm mark. The balance point is found to be at the 30 cm mark. Calculate 1. The mass of the meter rule. 2. The distance of the balance point from the zero end if the body were moved to the 30 cm mark. Okay, let's go to the solution. Okay, now let's take it line by line. A meter rule is found to balance at the 48 cm mark. Okay, let's say we have a ruler like this. Always draw the diagram 0 to 48 cm. Okay, it's found to balance at the 48 cm mark. Okay, it means that for it to be balanced, we have the, let's say the mass, let's put the mass here, the mass of the body m in gram. Let's say the mass will be here. Now when a body of mass 60 grams is suspended at the 6 cm mark, we'll locate the 6 cm. Here is 6 cm. And when another body is suspended, the body is 60 grams, is suspended here. When a body of mass 60 grams is suspended at the 6 cm mark, the balance point is found to be, the balance will change. The balance point will change to 30 cm. 30 cm. Calculate the mass of the meter rule. In this question, this is the diagram. This is the correct diagram. We have the mass, that's the unknown we are looking for. Remember, we take moments about this point. So what do? Let's get the distance. Since we have the mass, let's get the distance. 30 minus 6. 30 minus 6 will give us here to be 24. That's from here to be here is 24. Then we have 48. 48 minus 30, that will give us 18. Then we have 18 this way. So let's take moment, clockwise moment about this point. is equal to anti-clockwise moment. Okay, let's solve now. Remember, we need mass and distance. So this side we have clockwise moment m times 18 is equal to this side 60 times 24. Just know you need two things. You take moment about this point. So we have 18m is equal to 60 times 24, which will give us 1440. So the mass we are looking for will be 1440 divided by 18. We'll divide it by 18 to get our final answer as 80 gram. Now we have gotten the mass of this meter rule. The II part of the question says, calculate the distance of the balance point from the zero end. So we are going to change this balance point. We'll draw another diagram and change this balance point and get the distance from the zero end. If the body were moved to 13 cm, if this body here were moved not to 6 again but to 13. So let's draw the new diagram and find out the answer. So let's draw the new diagram. Remember that here we have it to be 0 to 48 cm, and we have gotten m, the mass, to be 80 gram. So we have gotten this side to be 80. And then remember that the distance of the balance point from the zero end, this is the zero, the new balance point, let it be here. We don't know. Let's just label it as x. That's the new unknown. The distance of the balance point from the zero end. If the body were moved to the 13 cm, let's locate here and put it to be what? That's the 60 gram mass that balances it. And here now is 13. So if here is 13, remember that x is greater than 13 because x is from here to here and 13 is just from here to here. It then means that this distance that we need will be x minus 13. Don't make mistake and say 13 minus x. No, the one up is bigger, x minus 13, because 13 is just from here to here and x is from here to here. That's the new distance from the balance point. Now what about this place? Remember, here is 48 and from here to here is already x. So how do we get the center? We are going to do 48 minus x. That's from here to this distance. So now can we take our moment about that point by saying clockwise moment is equal to anti-clockwise moment. So 80 times 48 minus x is equal to 60x minus 13, so that we can get the unknown x. So we solve it down and say 80 times 48, that will give us 3840 minus 80x is equal to, we open up the 60x minus 60 times 13, 60 times 13, that will give us 780. So we have this place 3840. This one crossing will be plus 780 is equal to 60x. This one crossing a quality sign, we can have it to be 80. This is 80x. 80x. So here now we have 80 plus 60 to be 140x. Then 780 plus 3840, that will give us 4620. 4620. So we can go ahead and find our x. X will be 4620 over 140. So that our final answer will be 33 cm. So we have gotten the answers to this question. If you have any question, please drop it in the comment section. I will attend to it. If there is anything you don't understand, please drop it in the comment section. Like this video, subscribe to this channel, and give this video a thumbs up. Okay, let's take another example quickly. Okay, the next question, a uniform meter rule AB is balanced on a knife edge which is 55 cm from B. If the mass of 10 grams is hung at P, which is 10 cm from A, calculate the mass of the meter rule. Okay, once you get the diagram, every other thing is story. Okay, now let's say 0 to 100. Why are we using 100? Is a uniform meter rule. Is 100. Now, and once it's uniform meter rule, remember that the mass must be on this 50 cm. The mass, that's the weight, must be here. AB is balanced on a knife edge, which is, the knife edge is where 55 cm from B. If here is B and here is A, the knife edge is 55 cm from B. So we'll start here, which means it's somewhere here, which is 45. Remember, it's 100. So if it's 55 cm from B, from this point, it then means that it's 45 cm from A. Once you miss it here, it's going to affect you. So that knife edge must be 55 cm from B and 45 cm from A. Okay, if a mass of 10 grams is hung at P, which is 10 cm, let's get here. This is our P, which is 10 cm. And what's the value of the mass? 10 gram mass. We have a 10 gram mass there. Okay, a 10 gram mass is at 10 cm from A. Calculate the mass of the meter. Remember that the mass must be at the center. So it's this mass that we are looking for. Is this mass that we are looking for. Now, what's the distance from here to here? 45 minus 10, here is 35 cm. That's from here to this point. Now, what's the distance from here to here? 50 minus 45 is 5. Once you get the distance, the next thing is to take your moment about this point. So that m times 5, we'll now do our calculation. 5 times m is equal to 35 times 10. So that 5m is equal to 350. And then m will be 350 over 5. 350 over 5, which will give us 70 grams. This is the answer. Let's take one more. See another way it can come out. It's good you look at the various ways it can come out, so that anyhow it comes out, you'll be able to tackle the question. Now, the last question, a uniform meter rule of mass 90 grams is pivoted at the 40 cm mark. If the rule is in equilibrium with an unknown mass m placed at the 10 cm mark and a 72 gram mass at the 70 cm mark, determine m. This one is very, very important you listen, because it's different from the ones we have solved, and it's very, very important. So let's take the solution to this particular one. Let's draw our diagram. Remember, it's a uniform meter rule again. So we are taking from 0 to 100. Now, the mass, a uniform meter rule of mass 90 grams. Let's look for 50. The center is where the weight is. So we are putting 90 at 50 because that is the mass of this ruler at the center that will keep it in equilibrium. It is that mass at the center that will keep it balanced. Okay, so let's keep drawing the diagram. And now it's pivoted at the 40 cm. Let's locate 40 cm and put our pivot. If the rule is in equilibrium with an unknown mass m at the 10, you look for 10 cm and put the unknown mass m. We don't know, so we are going to find it. And a 72 gram mass at the 70 cm mark. We'll locate 70 cm. 70 cm is somewhere here, and then put the 72 We'll then put the 72-gram mass. So let's find our m. Before we take moment, let's get all the necessary distance. That's the step. Once you get your diagram correctly, you now look for the distance before you can apply the formula. Okay, now here is 40. 40 minus 10 from here to here. 40 minus 10 here is 30 cm. Now from 50 minus 40 here is 10. Please, we are taking moment about this pivot, very very important. So we cannot set 70 minus 50. No, we are not looking for, we are rather looking for from here to that 70, from the pivot to the 70. Take note, 70 minus 40, that will give us 30. Please, these points I'm mentioning is very very important. Make sure you watch this video until you understand it. Okay, now let's take our moment about this point. Remember, we have two on this side, so this one will go, then this one will also go. So we have, this one will now go. So we have 30 times m is equal to 90 times 10 plus 72 times 30. Good, very very important. So we have that 30m is equal to 900 plus, we'll check 72 times 30, that will give us 2160. Okay, let's keep solving. We'll add up everything. 2160 plus 900, that will give us 60, and here is 30 m. So the m we are looking for will be over 30. This will cancel. That will be 1. Our final answer will be 102. This is the mass of the metal. Please remember to be careful with taking moment about this pivot. Once you get it, product of force and distance, then we just use mass and distance. In some cases, like the first example where force is given, you use it. Thank you for always staying on our channel to watch our tutorials. Please subscribe to this channel, hit the subscribe button and turn the bell notifications for more videos. Thank you.